forth. And we see that in unicellular organisms, so if you define sex as changing DNA, then you see that sex and reproduction are separate in unicellular organisms. But of course, from a practical point, the moment of reproduction and changing information of DNA is combined in multicellular organisms, because only at the moment of the egg cell fertilized by a sperm cell, that's the exchange of DNA is possible. So that's also a very important key moment in the history of life, and also a condition to be able to have evolution. And also the origins of multicellular organisms or so. At first you have a loose connection of cells, you know the sponges, that is about comparable with stadium 3 perhaps, because if you are teasing a sponge, you are destroying a sponge, then from every sponge cell they can grow new sponge. So the process of living together of some unicellular organisms, the co-product of is that there was specialization of several cells. Let's see. I have to look at the time, so I will skip this slide. It's about that life in itself is everlasting. If you look at our, you could say our body is a temporary house or hotel for our gametes. Our egg cells and sperm cells are in a way living forever through generations. That's this slide about. Like unicellular organism, they are in a sense undieable, because they are dividing, and that phenomenon is still there in multicellular organisms. Through our gametes, we are we are living forever. And this evolution, this has led to all forms of eukaryotes. This is another slide about it. And what is also a very important step in the evolvement of life and evolution is the first bilateral symmetric animals. Because if you look at ourselves, we are made for movement. We are made for movement. Movement is about strength, information and energy. Strength, information and energy. We get information, and that's determine how we move. If there is a lion escape from the zoo, we run away. We get the information, there is a lion coming through us, and we run away. But in order to be able to run away, we need energy. So all our tissues in our body has to deal with that. Muscles with movement, brains with information, and the intestines with energy. That's about the essence of life, and obviously the bilateral animals did that the best. That's why they are so important. And then when we have this, then we have real ecosystems starting. These organisms start to interact with their environment. So this is about, perhaps you have heard of the Ediacara fauna. It's about pre-Cambrian age, the Ediacara fauna. These are life forms from the Ediacara fauna. And this is important, why then the ecosystems get started. So this is just an example of it. This is called Garnia, because in these Ediacara faunas, or living forms, there are living forms that you cannot compare with other forms. So already in the early history of life, there are already mass extinction. This is a very interesting slide. So you will get it from Elena, but you should download this publication. Is this available through internet? And you see that there is this about snowball Earths and about so-called nebula winter, because star explosions have effect on the availability of sunlight, of energy reaching the Earth, so you can link important planetary accidents and snowball Earth. You can link that already through on important early mass extinctions, and that this is the time about more than one snowball Earth, and there were parts where the water was not frozen, so you could say that you had some places where you have a giant aquarium where life stayed alive, where it did not die out, and where evolution took place. You see at the here. Oh no, I have this from I will use this, of course. Let's see how it works.
The top one.
This one. Yeah. You see here how this is some kind of ground of all life forms that we know today, and you see the explosion of life forms linked to all kinds of disasters concerning the Earth. Because at those spots where there was still water, where populations of unicellular organisms got isolated from each other, then evolution took place, and then we come in the Cambrian, and in the Cambrian, so to say, we have the first real paleo ecosystem, because in the Cambrian we have the first real predator, namely this weird shrimp called Anomalocaris, which literally means weird shrimp. It was an animal about 1 meter and 50 centimeters. That's a giant for a Cambrian organism. So this is the first real ecosystem. And that's how ecosystems evolve. And from that moment on, we have things like this. Only the actors are changing during the course of evolution, but from the Cambrian on, we have this phenomenon. And that's a nice time to have a coffee, I think. Thank you for your attention.
So coffee will be in room 10.
Okay.
Downstairs.
Room 10.
Yep.
So, beneath.
Downstairs, yeah.
Downstairs.
Hopefully it's there.
Hopefully it's there. George.